So we have some APCs in thymus, and these APCs, present a large amount of self-antigens to the immature T cells, and after that we have apoptosis of these T cells. So first we may have apoptosis of T cells, okay? What about B cells? What happens to the B cells? The same thing happens to the B cells, okay? But B cells do not need, apoptosis. B cells do not need APCs to present antigens to them, and they can recognize soluble antigens, as I told you last session. So after introduction of self-antigen to immature B cells, first B cell tries to edit its receptors for the antigens. Which type of receptors are present on the surface of B cells? Antibodies, yes, I told you that the types of receptors that are present on B cells are IgD and IgM, yes. So, first B cell tries to edit its receptor, and if it cannot do this, it undergoes apoptosis again, okay? So, about T cells, we have apoptosis. About B cells, first we have receptor editing. If it's not successful, we have apoptosis. Yeah? So this is what takes place in central tolerance, in thymus and bone marrow. What takes place in peripheral tolerance? First of all, do you know what regulatory T cell is? Regulatory T cell, I told you that it is a type of CD4 positive T cell that regulates the immune response, suppresses the immune response, okay? One of the mechanisms of peripheral tolerance is suppression of T cells which recognize self-antigens by regulatory T cells, okay? Another mechanism is about, do you remember the interaction between T cell receptor and antigen presenting cells? We had MHC on the surface of antigen presenting cells and T cell receptor, and we had signal 1,
signal 2,
signal 2 by interaction of CD28 and CD80 or CD86 B7 molecules. Yeah, this was the signal 2. Okay.
Yes.
And if a T cell recognizes self-antigen, there are some inhibitory molecules on the surface of it. For example, which molecules?
PD1,
CTLA4, PD1, which inhibit signal 2 transduction. Okay? So it causes inactivation of immune response. Okay? And sometimes when we have recognition of self-antigen by T cells, by activation of extrinsic pathway of apoptosis, we have deletion of these cells. Okay? So we have different mechanisms. Okay, can anybody explain these mechanisms for me? I hope you. If I'm here, I hope you. central and peripheral. Yeah? Central by
TCL. TCL.
PCR,
TCL.
T cell and B cell, both of them.
Yeah.
About T cells, we have apoptosis. About B cell, we have first receptor editing, and if it's not successful, apoptosis. And peripheral, we have
Dendritic cell.
regulatory T cell,
Good TCL.
and we have inhibitory receptors, for example, CTLA4, which inhibit signal 2, and sometimes we have apoptosis again. Okay?
And what's the function of FOXP3?
I will talk about
Okay.
it. Okay, so I told you that we have central tolerance, in which we have most of the time.
Tumors and bone marrow.
Sorry?
In the bone marrow and the tumors.
Yes, exactly. We have central tolerance mostly by death or apoptosis of self-reactive B cells and T cells. Yes, and this mechanism is called negative selection. Okay, we have positive selection where Amar, your name was Amar or Amer? Amar?
Same.
Same. Okay. Amar wants to talk about selections, positive and negative. Positive selection is about which antigens other than self-antigens, yes?
Yes.
Last session, I told you that we have clones of T cells and B cells. Each clone is reactive against one antigen, and it was clonal selection, yes?
Yes.
And negative selection is
For this TCL, like decide whether TCL can work out or not, right?
about, yes, T cells or B cells which recognize self-antigens. They undergo apoptosis and it is called negative selection. Yes? And we have one important molecule on the for presentation of self-antigen to our T cells in thymus, and it is called AIRE or autoimmune regulator. And by this function of this molecule, we may have some autoimmune disorders which are called autoimmune polyendocrinopathy. Okay, so what is AIRE?
Autoimmune
What is its function?
coordinating disorder, autoimmune polyglandular syndrome.
Yes, its dysfunction leads to autoimmune polyendocrinopathy. Its function is
Self.
it is here. Yes, it helps expression of self-antigen on the surface of APCs in thymus. Okay? And I told you about B cells. If they recognize self-antigens, they will undergo apoptosis. Sometimes they may, perform receptor editing, and if it's not successful, they undergo apoptosis again. Okay, I told you that we have central and peripheral tolerance. Yeah.
Yes.
It means that the central tolerance is not perfect. After central tolerance, after maturation of B and T cells, we will have some mature B and T cells which are reactive against self-antigens, and they should undergo peripheral tolerance. Yeah? And what happens in peripheral tolerance?
Before tolerance, the
I
gene.
told you
Or
no.
regulatory T cells.
3 steps. Regulatory,
What T cells?
yes, and apoptosis. And the functional inactivation of T cells which are reactive against self-antigen is called anergy. Okay, so what is anergy? Inactivation. It means that they do not undergo apoptosis. Instead, they become functionally inactive. How? By presentation of inhibitory receptors. For example, do you remember this picture? We talked about it last session. No? Yes, MHC. Yeah. So, we talked about the interaction between T cell receptor and antigen presenting cell. I told you that we have signal bond by recognition of
CD4.
Antigen on the surface of APC by presented by MHC. Yes, MHC class 2 for CD4 positive T cells. And I told you that we have this interaction and signal 1, but it is not enough. Okay?
Yes.
And we have signal 2 by interaction of CD20A and CD8T or 86 or generally B7 molecules on the surface of APC. In autoimmune disorders, we have
We have this activation of the signal too.
yes, exactly. And in immune tolerance, we have
Activation of it, right?
yes, inactivation by presentation of
CTLA.
CTLA4 or PD1 on the surface of T cells, which are inhibitory. So, CD28 is normal, CTLA4 or PD1 is inhibitory. Yeah?
At the same time, the signal 2 goes increase in the start and
Yes. And I told you that in some tumors
we have mutation in signal 2, right?
yes, and the tumor escapes the immune system.
So not get to apoptosis or
Yes.
tolerance.
Yes, exactly. Okay, and here again,
And what you said about the C5A, it have indirect relationship with opsonization, but not the isn't its function isn't to opsonization.
sorry,
The function of C5A isn't opsonization, as you said.
opsonization. No. C3b.
C3P only do opsonization.
This was the question you asked me, and you searched.
Yeah,
And you came to the conclusion that only C3b
exactly.
and C5a is anaphylatoxin, yeah?
Yes, anaphylactic.
And here again, you see we have CTLA4 on the surface of T cell, and it has an inhibitory function, okay?
Yeah.
And yes, and sometimes I told you that in tumors we have some medications that block CTLA4, and in this way, By by presentation of CTLA4 they escape and the medication is against the CTLA4.
You are saying if CTLA4 got inhibited, that means the overreactivity of T cell cause reaction, I mean autoimmune reaction against the tumor?
Yes, exactly. That is a good point. In some tumors, we have medications against CTLA4. Okay, and it is good for the patient because it causes the immune response against the tumor. But at the same time, the patient may get autoimmune diseases. Okay? And this is, a bad thing about these types of medication. Okay?
So a tumor that related to the gland, we're gonna use antibody to inhibit the CTLA
In what?
thyroid gland.
Thyroid gland. Okay?
We're gonna use medication that cause inhibition of the CTLA
For what?
to kill the tumor gland. Tumor gland,
Tumor cells?
tumor cell.
In thyroid?
Yes.
There have been different types of,
Because it said in
diseases. As I know that it is used in different types of disease. Gastric cancer, I know. Prostate cancer, I know. In skin, some, squamous cell carcinomas.
because it said in the
In
book.
melanomas.
Because it said in the book it's cause Fox gene mutation that cause glandular. No, this is about air. Mixing. It's not related. This is the
No, that's something else.
yes, not
Yeah.
related. But yeah, I think it's
Yeah,
related.
that.
Yes, polyglandular. I mean, it's related
Yes,
to thyroid.
autoimmune, yes, maybe. Different endocrine systems, thyroid, for example, adrenal.
So that's why we used the inhibitor of CTLA.
So that's for tumor.
Okay. Yeah, this is what I knew.
Okay. And okay. And I told you that we have some regulatory T cells, and these regulatory T cells suppress the immune system against self-antigens. Okay, and we have Dr. Omar. You have FOXP3 here. Yes.
Yes. We
For the
have
development and maintenance of functional CD4 positive regulatory T cells. Okay?
yeah, and then we can
And by mutations in FOXP3, you have again autoimmune disorders, IPEX, immune dysregulation, polyendocrinopathy, enteropathy, and it is X-linked. Okay? And sometimes, the inactivation of immune system is by cytokines, for example, interleukin-10 or TGF-beta, which are anti-inflammatory cytokines, okay? And sometimes they undergo apoptosis. Okay, so I told you that we have introduction of self-antigens by APCs in thymus, and for B cells we have introduction of self-antigens to the cells in bone marrow. But we have some immune privileged sites in which the antigens are not introduced to the immune system. These organs are testes, eye, and brain. Okay, because these antigens do not communicate with the blood and lymph, they are not introduced. So after, for example, an infection or trauma, we may have introduction of the antigens of these organs to the immune system, and we will have, the inflammation of these organs. For example, we have post-traumatic bronchitis or uveitis. Okay? Did you understand? To some extent?
At first, actually, we said we don't have it, but after any infection, it's
Yes.
the difference between them and
Yes, for example, about other antigens, okay? While the immune system is, maturing, we have introduction of the antigens to the immune system, so we have tolerance. But about these, we do not have. And after, for example, trauma or, for example, infection, the antigens enter the blood or lymph, and they go to the secondary lymphoid organs, and we will have immune reaction against them. That's why, for example, have you ever heard that if there's trauma to one eye, we may lose the other eye
Yeah.
because of immune reaction? That is the reason. Okay. Okay, now we talked about immune tolerance, yeah, and self-tolerance. What causes autoimmunity in general? It may have different causes. One of the important causes are genes, okay? Most of the immune disorders, autoimmune disorders, are genetic disorders, and you see that they are familial. They are related to genes, okay? Genes that regulate the immune system, okay? Mostly HLA genes. And genes are not responsible. Are not the only responsible cause. Okay, and we have some environmental factors. Okay, for example, we have infections or tissue injury that may predispose to autoimmune disorders. How is it possible? How is it possible that after, for example, tissue injury, we have autoimmune reaction?
if they have the same antigen, for example, about the rheumatic fever, I think.
That's about infections, yes,
exactly.
and that is true. For example, we have some infections, and the antigen of that microbe has similarities to our self-antigen, so the reaction of body against that antigen may cause injury to our body. How about trauma or injury to our tissue? After trauma, we may have some antigens that are introduced to our immune system. For example, after trauma or injury to the cells by UV light, we have introduction of nuclear antigens to the body, to the immune system. Okay? So, as you see here, for autoimmune disorders, we have genetic susceptibility, and also we have environmental factors. Environmental factors may be tissue injury or infections. Yes. And I told you we may have genetic factors. Most of the genes that are responsible are HLA genes, mainly class 2 HLA genes, especially HLA-DR, DQ, and sometimes they have strong association with the immune disorder. For example, about association of HLA-B27 and ankylosing spondylitis. The association is strong, and sometimes it is not. For example, about rheumatoid arthritis and HLA-DR1, it is a weak association. Okay, so sometimes there is a strong association, and sometimes the association is not that strong. And about infections, tissue injury, and environmental factors, the thing our friend said about rheumatic heart disease. What did our friend say? The role of infection in autoimmune disorder, similarity. Yes, it is called molecular mimicry. Okay, molecular mimicry is because we have similarities in antigens of microbes and self-antigens. For example, we have this in rheumatic heart disease. For example, we have streptococcal pharyngitis, and after a few weeks, the patient comes to us with symptoms of, disorders of heart valves or things like that, different kinds of heart problems. Okay. And here you see the mechanism of, the role of infections in autoimmunity. This is molecular mimicry. Yes, as I told you, we have similarities in antigen and activation of T cells that are, reactive against cell tissue, and we have autoimmunity. Or sometimes we may have activation of B cells and production of plasma cells and production of cross-reacting antibodies that act like autoantibodies, yes, and cause tissue injury. And another one is that infections activate the co-stimulatory molecules on the surface of APCs, and that's why they may, activate the self-reactive T cells, and that's why infections may lead to autoimmunity. Okay?
The same as EBV?
EBV. EBV. I don't know. Have you read it somewhere?
It causes increase in B cell production because LAP antigen is mutated, right?
I haven't heard that EBV is can cause this kind of autoimmunity. But if you have seen it somewhere, please show me. We can learn.
No, happens. I'm gonna do a research.
Do a search, but this is the last session. You should do it now.
How can I do it now? Give me your number. I can't send you the research.
Okay, so this is another way that infections can induce the activation of co-stimulators on APCs and cause autoimmunity. And we have different types of environmental insults. For example, UV radiation, which is seen in lupus, for example, and smoking, which is seen in RA, and sometimes local tissue injury can cause autoimmune responses. And another thing, are autoimmune disorders more prevalent in women or men?
Man?
Women,
Why?
for unknown reasons.
For unknown reason. God hate you.
No, you may have heard that the immune system is stronger in women. Yeah, but in Robbins it is said that the underlying mechanisms are not well understood, but it may be the effect of hormones or other factors. Okay? It may have something to do with the genes located on X chromosome, or for example hormones or things like that, but all of them are theoretical. Okay.
So I was saying that the progesterone is the main reason for increased autoimmune reaction in the women that cause increase in no that cause autoimmune disease.
Sorry?
Progesterone lead to increased autoimmune reaction.
Autoimmune reaction?
Progesterone in women, right?
Progesterone. Oh yes, it may have something to do with estrogen or progesterone, but something to do with that, but it is not understood. Maybe you can search it.
I will do. This is a research. Please give me a mark for that.
Okay. Next. Oh, break. 3 minutes. 5 minutes.